today. So you're Saurabh, right?
Yes,
Awesome. And the company name is Monster API.
exactly.
Awesome. So what is Monster API and what does it do?
So Monster API is an API-first computing platform for machine learning developers that helps them train, tune, and deploy their latest AI models at a fraction of a cost. This runs on a distributed cloud that we have built. We have partnered with thousands of crypto mining farms, rendering farms, gamers because they have millions of idle GPUs. We brought them on the network and provide access to these GPUs, computing systems, as well as the latest LLMs in the form of an API, making this the most easiest, simple, and affordable platform for building your AI models.
Great. So can I call it as a decentralized compute layer or something like that?
We call it a unified computing interface, where it's a single interface where you would submit your jobs. It could be a training job, a fine tuning job, or an inference job, and it would be processed by our network of, you can say, workers. Those workers are computing systems. Specifically, they are GPUs. uh, in one line, our mission, I would say, is to bring the cost of intelligence by an order of magnitude so that we can help the next generation of 100 million developers build and integrate AI models in their applications.
Perfect. So why should a developer use Monster API?
There are many problems. One of the most common is cost. So, as a developer, when you go to when you're building your model, or let's say you're deploying the latest LLM, you end up with AWS of the world. There are only three major clouds today: AWS, Google Cloud, and Microsoft Azure. One, they are extremely expensive. They use the top end industrial systems, which are designed for enterprise customers, but most of the developers end up using that. The analogy I would say is, I would use it. They are like Bugatti and Lamborghini of this world. And if you are, going to buy groceries, you don't really need a Bugatti. Just your Tesla is fine, or a regular car is fine. So our proposition is that don't go to AWS for building your regular models. You have thousands of idle GPUs among smaller data centers, rendering farms, crypto mining farms, which could be put to use and optimized for running ML models. And when you do it this way, it's 90% lower cost compared to running it on AWS. To give you an example, one of our customer, they were spending more than $400,000 on AWS. When they shifted their workloads to our network, now they're getting the same amount of computing flops, same speed and everything for $65,000, saving them more than $335,000 on an annual basis. That's what we want to do for millions of developers. When you're starting your journey, you don't want to spend shitload of money on these clouds. So one is cost. We are building an affordable option, an alternative. Second is, even let's say you have some capital to use these systems, and you want to use these systems. It's extremely complex today. You don't just use the raw GPU. You take those systems, then you set up your containers, CUDA environment, 10 different AI frameworks, libraries, drivers. All of these are open source. So you have, and because they are updated almost on a weekly basis, they tend to become incompatible with each other. As a developer, you have to deal with all these issues before you can even start your job. And when you want to scale, it becomes very complex. You have to learn orchestration, you have to learn Kubernetes. So what we are building is, the vision with unified computing interface here is, you never have to deal with first finding these GPUs. There's a GPU shortage today where you can't even find these systems. So you don't have to deal with finding these GPUs. You don't have to deal with setting them up, and you don't have to learn MLOps, or you don't need to hire an army of MLOps engineers to get your job started. You can take our API and integrate that within your workflow and get started while saving significantly way more.
Awesome. Nice answer. So I'm hoping you are an engineer background, right?
No, I come from particle physics background.
Okay.
I have been obsessed with high energy particle physics all my life. I got fortunate enough to do my master's in nuclear science and got a chance to work at CERN, where they found the God particle. Media called it with this weird name, God particle. They found the Higgs boson, and yeah, that's my background. And interestingly, I stumbled upon this project there called as LHC at Home, where Uh, they had petabytes of data which they needed to process. And instead of building more server farms, they invited people from all over the world to donate computing power from their laptops. So you can download a package, a software, or an application from them. You're sleeping, but your laptop is computing for them. And more than 5 million people have donated computing power to the scientific projects at CERN and many other places. The biggest project is Folding at Home. It was started by an Indian professor at Stanford. Uh, they they are doing protein folding, and when COVID happened, they shifted their focus, for a while towards COVID. And the interesting part is the enthusiasm to solve for COVID was so strong that a lot of crypto miners also donated computing power to them. Gamers donated them, Xboxes, PlayStations. All these systems are incredibly powerful, and they were donating that to solve for scientific projects. Now the idea is that's how we came to this idea. Now, how do we bring this tremendous power lying latent in our consumer systems, which are becoming powerful every single year, to the machine learning space, where there's a shortage of high quality GPUs?
Wow. I didn't know you studied particle physics. I mean, that's awesome. So, did you do it in India or over here?
So, a part of my studies initially, my bachelor's was in India. Then I did my master's from University of Paris in France, and then later on I uh, worked on my PhD for a while. It was in neutrino oscillations, but then I dropped out because I wanted to solve a major problem. I became an entrepreneur. The major problem was I came back to India to solve this problem. In India, it was one of the big problems is rape, women's safety and rape, and we wanted to build a wearable device which is very small. You could fit inside a pendant or a watch or a bracelet, and it would have a GPS unit in it. On trigger, it will send your location or victim's location to family, police, or other associations. So that's what we built. I came back to India, worked with IIT Delhi for a while to build this product, and then later on, shifted to other projects and other, you can say, startups. So this is my third startup.
Awesome, awesome. I'm great that you took the time and talked to me. So, tell me a little bit about IIT. It's I'm very curious about IIT. IIT is like once Bill Gates said, if I mean, somebody asked him if you get a chance to hire from one specific university, all of the workers for Microsoft or whatever your projects are, which will be that university? He said like IIT. That's what I heard on the blog or a news. I don't know how much truth on it, but I always admire anybody who's from IIT. So tell me a little bit about IIT. What it feels like to work with IIT and people from IIT.
Interesting. I've worked with many organizations. So one of the core, I would say, difference which makes one organization very different from other, I would say, comes down to culture. And when we by culture, what I mean is the way they approach a problem. Uh, so these people, these students at IIT, they have been trained in some of the most difficult manner. That training gives you a lot of confidence and resilience that now you can tackle any problem in life. Just taking a page from my particle physics career, once you have solved differential equations, or you have understood quantum mechanics. Well, no one understands quantum mechanics, but once you have gone there, and uh, worked for quantum systems, it gives you that sense of confidence that now you can tackle any problem. The same thing it's something similar that I experienced at IIT with IITians. Once they have gone through very rigorous training, they have solved very complex problems across different domains, from computer science to mathematics. Uh, Now it gives you that resilience, and you can tackle any issue, and that's what they love. The culture is very different. Uh, the culture in many organizations is to choose something which can make you money quickly. The culture there was, how do I work on the most difficult, most challenging project that can, uh, it's, so people are working on projects for the love of it, and that's when you can really innovate. Because if you're, I mean, the philosophy is, if you are working on something to just get an outcome, you would take shortcuts. You want to get things done quickly. But when you do it because you love it, when you do it for the sake of challenge, for the fun of it, you really go deep. And this is, I would say, the kind of culture that I'm talking about. That's what I saw there.
Gosh, I'm so glad. I'm so glad that you're having time over here. Awesome. It's going pretty well. Okay. I wasn't expecting this well though. It's pretty good. Okay, let's shift gear a little bit. Let's get back to Monster API. So, um, what makes it different than your competitors? If you want to talk about it a little bit.
So all the you can say incumbent clouds today, they're all centralized. They run on a very capital intensive model where they spend billions of dollars in building their large data centers, and they house all the industrial systems, which are again very expensive. And those industrial systems are designed to work in these large data center environments. Their heating and cooling mechanism are completely different. Their racks are designed completely different in a different manner, and all that. And they're designed to serve thousands of different use cases. All of these things leads to much higher cost. So uh, the way we approach this is, you can say, we started as Airbnb kind of model, completely capital light. We partnered with crypto miners, gamers, rendering farms, uh, took their machines, built our own packages on top of that, and then anyone on this side, the developers could rent out the GPU systems. That's how we started. The At the base level, the model is almost similar, where we don't own anything, we don't invest in this infrastructure. It's a capital light model. But what we have done is, at the base level, there's a GPU pool which comes from all the different providers. On top of that, there's an orchestration layer, then there's an optimization layer, and finally the API layer. So, as a developer, you never have to interface with the GPUs. You get the APIs, which performs these jobs for you. And because we are running these on this distributed network of commodity GPUs, it leads to 10 times lower cost. And because the delivery mechanism is through API, it makes your job super easy. So that's how we differentiate from all the incumbents. Uh, and it has been, like, I'm not the infrastructure guy, I'm a particle physics guy, and it has been designed for people like me, to be honest, so that when I want to experiment, I want to simulate, let's say something, I need computing systems. I don't want to waste my time in setting up the infrastructure and learn Kubernetes and all of that. Give me an API so that I can integrate that within my workflow and application. And that's how easy, we want to build this for, not just for developers, for creators, for builders, for physicists, for chemists, for engineers, for founders also. The wave that we are looking at today is, uh, in next 5 years you will have a lot of, I would say, even billion-dollar companies run by two or three people, or maybe single person unicorns. Why that would happen is because the cost of intelligence is going to go down because of efforts like these, and it's going to become super easy. So you don't need your infrastructure guy. You don't need to hire an army of MLOps engineers to get started on the latest models. So keeping all that philosophy in mind, we have built this.
Great, great. Okay, so what challenges did you face when you create Monster API?
It's been a journey. There are many challenges. Uh,
Talk about some of them.
uh,
Yeah.
yeah, well, some of the, I would say, technical ones is when we started. We were I started this with my brother. He's a machine learning researcher. He ran his last startup in computer vision. So, like, I'll give you. It's a good example. So, like, right now you're using a feature of Zoom which blurs your background. So sometime back he was building these models, computer vision models, which can blur your background, and that required him to train these models on AWS, and he was spending around $2,000 on a monthly basis on AWS. And from my experience in distributed computing, I shared this idea that, hey, let's try that for machine learning, for your models. Let's try to bring your cost down. So we took a crypto mining rig and started, the number one challenge at that time was, can we train a machine learning model on a crypto mining rig? Now we failed. So initially we failed. Why we failed was, the root of the problem was that these GPUs inside crypto mining rigs are gaming systems. These are gaming GPUs. They were never designed for machine learning. The blockchain community optimized those gaming GPUs for their use case. Now the same needs to be done for machine learning. So we built our package which creates the CUDA environment, adds in containers, drivers, libraries, AI frameworks like PyTorch, Keras, and many more. Once we did that, after a few iterations, like fifth iteration, we were able to make this work. So we faced these challenges, overcame them, and then his bills actually dropped from $2,000 to $200. And that's when we realized we have something solid and we can help millions of other developers achieve the same.
Okay. So that takes me to my next question. What's the future of Monster API? I know as a startup, you cannot talk about so many stuff, but whatever you can talk about, you know?
Uh, First, I would say this entire space of machine learning, generative AI is going to change the world. It's going to disrupt every single industry now, from entertainment, from Hollywood to regular applications to scientific endeavors in physics, chemistry, biology. People have started using generative AI now and machine learning models in general. Uh, our belief here is that by 2030, 8 billion lives would be touched directly or indirectly by AI. And those lives would be touched through applications built by more than 100 million developers. So we want to make the job of those 100 million developers easy and affordable. So the idea behind Monster API is to give you one monstrous API that you can use for training, tuning, and deployment of these models. And you never have to worry about infrastructure ever again. And so first we are doing this for machine learning, but we do envision, capturing all the other use cases. Like I mentioned, the scientific community itself can benefit from this. Your VFX, gaming industry, entertainment industry. So the way we look at compute is today our modern world runs on electricity. The next, you can say, generation, the next world we are moving towards very rapidly would run on compute. So compute would be like electricity. And there are millions of consumer systems today which are becoming powerful, like your MacBook with the latest M2 chip can run stable diffusion, can run many popular models now. Imagine the next generation of MacBooks. Imagine the next generation of Tesla cars. They're like a supercomputer on wheels. So the vision on the supply side here is that we want to tap into millions of PlayStations, Xboxes, Tesla cars, and Apple MacBooks also, uh, building a giant decentralized computing network on top of which you can deploy and run your AI models to help these 100 million developers.
Okay. So we already talked about cost. Can you talk a little more about how Monster API is helping ML developers to save cost? Just let's be very specific.
Yeah. So I'll give you one example. So let's take a Whisper AI model. Whisper AI is pretty big. Now to run that, you need bigger GPUs like A100s, H100s, which are very expensive. And there is a consumer GPU. You have a friend, let's say, and he has a crypto mining rig. He has a consumer GPU, let's say 3090. You can't really run because the 3090 is a smaller GPU. It has smaller memory size. You cannot run a model like Whisper AI on that. So what we have done is we have built our own optimization framework, which reduces the memory footprint of a model to a level that now you can fit that inside a smaller GPU. Because we are able to do that, now you can run the large model on a smaller GPU with a smaller footprint. And because we are able to use that, it leads to lower cost. So that's one. Second is the cost of hiring ML ops engineers. So let's say you are fine tuning models. Today, fine tuning process requires 20 different steps and major challenges like out of memory issues, finding the most optimal hyperparameters when you're fine tuning them, auto batch size kind of issues. What we have done is we have completely simplified this process from 20 steps to just 3 steps. You can select a model, select your data sets, or upload your data sets, and you can start fine tuning with Monster API's no code fine tuner. This way, you don't have to go through running 10 different experiments to find the most optimal value for your hyperparameters. We have already experimented for different combinations of models and data sets, and we have figured out the most optimal parameter values. So you don't have to do that job. And because we optimize them further through our frameworks, we are able to run them on smaller GPUs. All these things leads to much lower cost, and it saves a lot of time because you don't have to go through this entire process. You don't have to worry about challenges like out of memory issues and finding the optimal parameters, and you don't have to run 10 different experiments. And the same example, typically the average cost of fine tuning a model on AWS is around $500. With us, it's somewhere between $30 to $50 per fine tuned models.
Wow. So it's basically, I can say like this is like making the ML models faster and better, right? And how it's happening, like how it's making it faster and better and cheaper, like at the same time, because that's the place that VCs look for in order to invest in a company. So cheaper, better, faster, right?
So we make it cheap by running them on consumer GPUs. That's one. But the problem is, without the optimization framework that we have built, you can't really run them on consumer GPUs. So that's the technology behind it. That's one. Second is, I'll give you that analogy where you're going for uh, grocery shopping, but you're using Bugatti. A
Mm,
lot of developers today, maybe because the companies are flushed with money, or because Nvidia and AWS have created so much hype that they end up using A100s and H100s even for smaller models. You don't need to do that. For them, consumer systems are pretty fine. Uh, Second is about how do we make them faster. We don't make them faster today. We are building our own frameworks which speeds up, or you can say increases, the throughput. One example is, uh, without the framework, stable diffusion, let's say, would deliver 10 images per minute. With our framework, it would deliver 13 images per minute, so 30% more. So we are working on different types of frameworks. One is memory optimization, so that you can run that on a smaller system. Second is increasing the speeds. Third is increasing throughputs.
okay. So
And
let's yeah.
fourth is optimizing the pipeline from reduce, like I gave the example of, with no code fine tuner. Instead of going through a 20-step process, you are and instead of running 10 different experiments,
Mhm.
uh, because we have done all the, you can say, grunt job for you. Now you can fine tune really fast, and you don't have to go through those 20 steps and five different major challenges. You can run this with a three-step process without writing a single line of code.
Okay. So let's get to a privacy question, right? So how Monster API handle the safety and the privacy of the data?
uh, Security is always challenging. That's And so we have our own security protocols, from end-to-end encryption to some of the protocols that are used by companies like Cisco. But a lot of times, even despite having those security protocols, the perception problem is a bigger problem. Uh, so for that, we now have got certifications. Uh, we have got ISO 27001, SOC 2. We are working on other certifications like HIPAA and PSI, PCI, and all our data center partners, they are completely compliant. So the entire pipeline, is compliant.
Okay. Can you talk about some of the feedbacks from your customers?
Uh, for To be honest, whatever we have built today is completely based on that feedback. When we started, with the Airbnb model, one of the major, challenges, or you can say question that came, was, you have all these providers on your marketplace. I want to scale up. As a developer, I want to move from one GPU node to 1,000 GPU node across different, geographies. Now, how do I do that in a marketplace model? I have to deal with 10 different hosts who will. Can you scale this up for me? I don't know how to to integrate Kubernetes. All of these challenges, or you can say feedback came through our user base, and that's how we evolved our story. So we started with the marketplace model, but now we are, you can say, an API first computing platform, where it's not a marketplace, where if you want to scale, our deployment solution would completely scale that for you.
Okay. So can you talk a little bit about like personal stuff, like person as a person Saurabh, and then um, a person from Asia, like talk about your like little bit of childhood education in India.
Uh, I always wanted to be a scientist, especially in high energy physics. And yeah, we my parents actually supported me in this. In India, I'm not sure if you know the culture. The culture is that you only have two paths, either engineering or medical. If you want to pursue physics, no one really gives or no one wants to support you. But my parents really did supported me. They said, if you're obsessed, if you're passionate about something, you should go to the extreme length of that. That's what we want. We don't want you to become anything else like engineer, medical. But if your heart is in physics, we'll support you. Just one condition: go to the extreme lengths. Don't become average. That was the only thing. They supported me with everything that I needed. And uh, that led me on this journey where I did my bachelor's in physics and master's in nuclear science. That gave me the opportunity to work at Atomic Energy Commission in France and at CERN in Geneva, which opened up, these were some of the best days of my life, I would say. Not just best days in a material sense, but in a spiritual sense. When you are there, when you're working with those people at the cutting edge of physics, it's almost you feel spiritual. I don't have any other words, to explain that feeling. And but yeah, I felt this very weird, I would say, gap. The gap is um, most of the physics world or the scientific world right now is driven by compute, and it would become largely driven by computing systems because you have to simulate a lot of models. You have to simulate your experiments. The experiments are becoming larger and larger and more expensive. Like you have your Large Hadron Collider now; they are planning a 100-kilometer radius uh, new, you can say accelerator. So because the stakes are very high, you have to you have to simulate every single thing using high performance computing systems. And now with AI, it's going to be mind boggling. But I saw this gap. A lot of physicists like me, they like that, but in their heart, they want to focus 80% of their time on physics. But what happens is that generally you end up spending a lot of time in coding, which is fine. But if your heart is more towards physics, that's the issue. But now I think with many projects, like coding co-pilots and many others, that problem would be solved. And a part of my personal motivation to build this out is to actually help a lot of scientists all over the world. I feel there's a lot of talent which is facing obstacles because they don't understand how to set up computing infrastructure. They don't understand the nuances of AI. AI can help them a lot in their journey, but they don't know how to integrate AI or use AI or set up computing infrastructure. So we want to bridge this gap. That's my personal motivation, other than helping a lot of developers in their journey. Yeah,
So you want scientists to be focused on their work, and you want to help them make their journey easier. It's like I watched cricket when I was young, so Sachin Tendulkar always had to focus on his batting. He doesn't care about fielding or bowling because he was the greatest of all time. So his teammates and his coach always made sure that you focus on your batting. Just don't worry about anything else, right?
exactly. You can only specialize, in one field when you give it your heart and time, and like time as in at least 10 years, 15 years. So sometimes a lot of these things, distract you, and you tend to do them because it's a symbiotic relationship. But I think with AI, a lot of these things can be solved.
Any advice for first-time co-founders or even co-founders who wants to build a company, who wants to become someone like you, or who's basically thinking of starting an ML or AI startup?
I think I can. Yeah, I made a lot of mistakes, so I can share those mistakes so people can avoid that. So like I shared, my first startup was building a wearable device for women's safety. But I'm a guy. All the engineers were men, and we were building a product for women. And the problem was that we were in our own bubble. We designed the solution from an engineering standpoint. Okay, we need to miniaturize this. We need to find the smallest GPS unit. Your battery, should work for, let's say, 48 hours, 72 hours. So we worked on, these parameters. The biggest mistake we made was we never talked to the end customer, which was women in our case. We were designing the product for them, but we rarely interacted with them. We never took their advice on how the product should have been built, and that led to, you can say, lower adoption of the product itself. And so that's one advice. We What happens is, coming from engineering or scientific background, we get fascinated by new ideas, and we start building them without ever talking to the end user. And because of that, there's always a gap. And so the advice is, just flip this. First, talk to those users that you want to serve, that you align pretty well with. So let's say I'm a developer. I want to solve for developers. Let's understand all the common problems they have, and then also align that with the problem that you are most obsessed about, because only obsession can lead you on that path where you can not just provide a 20% better product, where you go on the path of transforming an industry. And you can only do that when you're obsessed about a problem, and that problem really matters for a lot of people. So just change that. I made that mistake. So talk to the users more often, learn from learn all the challenges that they face on their day-to-day basis, and the dreams and desires they have. So there's a developer living in Zimbabwe. He wants to have a supercomputer. He wants to train an AI. How do I help him? So I need to talk to him, understand his problems, and then reverse engineer the solution. Second is, I would say, getting a sense of like a vague business model. At least if you can get extreme clarity on the business model from day one, great. That's the best way to start. But if you can't get, you should at least have a framework around that. How would you commercialize your product? A lot of times people have built brilliant solutions to great problems, but there was no mechanism to monetize that, and it becomes very difficult to sustain that without external, you can say, capital. And third lesson is specialization. Sorry. Specialize. The world we live in is where every job would be taken by AI in next 5 years. So only when you specialize one, and you can specialize in 2 or 3 fields, combine those rare skills together, only then you can survive. So we see a lot of generic solutions, but what you really need is specialized solutions, or focusing on niche and building for those niches.
Sure. So yeah, just I just asked the question. I'm repeating it. It's fine that you explained it pretty well, and I hope it will help our listeners. So, any heroes of your life, like any idols or hero that you look up to from the very beginning of your life? It can be a film star, it can be a cricket player, it can be a football player, it can be a billionaire or a president, whoever, or any couple of those heroes. Like you can put 5 names or whatever. I'm just trying to understand, like, okay, this is who you are.
Mm. So yeah, there are a few idols and heroes that have completely changed my life. I was an average kid, and I'm still average, but
No, you're not
learning
average.
and
No, 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 no.
becoming.
Don't say that.
I'm
You're not
going.
average. The major that you had, like, look, you're building a startup, that's fine. But the major that you had, like, studied that you had to go through, that's something like it's not easy. I know I'm a quantitative finance student, like quantitative methods and modeling. I have done fair parts of math, but things that you guys been through, man, I have respect for you guys. Trust me.
Thank you,
You're welcome.
thank you. So I would say, very going way early back. Yeah, Paramahansa Yogananda. I don't know if you know him, but he wrote Autobiography of a Yogi, very popular book. But
Right.
he has written a lot more stuff. He is actually a spiritual guru. He lived 100 years back,
Right.
but the content he has lived, is timeless. And that's my number one advice to anyone who wants to change his life. Just go through that journey. It's not really a long journey. You just need a lot of focus and intensity. 3 months, dedicate time towards its lessons. It will change the way you look at the world. Look at the world. It will change your focus. Uh, it completely changed me. So that's Paramahansa Yogananda. Second, I would say is Einstein. Einstein. So there are geniuses, and then there are, in my belief, there is a genius with no peers at all. He is a god among geniuses. There is no one like Einstein. So Einstein is a god. Uh, Third, I would say Sachin Tendulkar. We can all learn something from him. One of greatness is
Great,
like
humble guy. Great guy. Great guy.
best in the world, right? So best in the world. So Sachin Tendulkar. Then you have today you have Elon Musk. Uh, the fact people talk about changing the world. This guy is changing the world. He's not talking about this. I mean, you can't build reusable rockets. You can't build electric cars. You can't build battery factories. Uh, and any field that he touches, he completely changes them, transforms them. And the thing is, they're not software companies. They are very hard industries. And only nation states have ever went to you can say or done the reusable rocket thing, and he's the fourth entity who has done that. So great respect for him. So he's an idol, and I think controversial, I know, because
Yeah,
of
it's
the
fine.
latest
We all
activities,
are
but
human being. We make mistakes as a person. Like you cannot mix the person with co-founder. Like as a person, he can be somebody, right? You can like something, or hate something, or dislike something, whatever it is. But the outcomes are amazing. We should focus on whatever he has done good, right? And one
he
of
has
my
completely
yeah,
changed the world. I,
one of my friend, like older friend, he's a very smart guy. He moved back from New York. However, he said like, look, he's talking about 2014 or 15. Like, look, this guy Elon Musk, if he's 10% right, do you know what's gonna happen? It's 2013, 14 maybe, or 15. So if he's 10% right, he's gonna change the world, and he's gonna be the
hmm,
richest person on earth, like maybe the first trillionaire. So forget about the money part, but the amount of change he already brought, like with Tesla, right? And he's
yeah.
working on Twitter right now and other stuff like hyperloops and solar
40
panels,
forty
right?
thousand satellites, with
Right,
Starlink,
right.
uh,
So
reusable rockets.
and then neural link. Like if we can talk, we can go on and on, right? He doesn't have to do all these things. He can sleep all day. He can enjoy his life, but he doesn't, and that's what makes him Elon Musk. He's different.
in, in fact, personally, the way I look at this is 500 years from now, when we look at few pivotal moments in history
Hmm.
of our world, we would look at Einstein's general theory of relativity and special theory of relativity, because it actually changed everything, the entire physics, and then first it changed physics, but then it changed the entire world. All our GPS systems runs on general theory of relativity equations. All our astronomy runs on that. Every single thing today. Uh, and you look at the moment when someone established reusable rockets and landed us on Mars finally. We would look at that, and I think the third thing would be, and that's again my idol, would be Interstellar movie, and that's Christopher Nolan.
Christopher
So
Nolan, right?
Christopher Nolan, he's again the genius of geniuses. There's no one like him. I love movies. I love Hollywood, Bollywood. Every I love watching movies, but
Who's your
Christopher
favorite
Nolan is at
hero?
another level.
Who's your favorite hero in Bollywood?
Shah Rukh Khan.
Oh, nice. Did you see Jawan?
Oh, not yet, not yet.
Okay. Okay. Cool.
I
Cool.
couldn't. I was traveling at that time. Yeah, I couldn't. But yeah, I'm waiting when it's gonna be released on some OTT platform, because it's not here in theaters now.
Awesome. Hey, I would like to talk to you like 2 more hours, but time is short. I mean, it's been pleasure talking to you. I learned a lot about you, and the vision of the company. And I hope this podcast, or you call it YouTube video, or a friendly chat, will help so many people. I'm hoping, and I really wanna say thank you from the bottom of my heart for taking the time today.
So thank you so much. I enjoyed it.
Thank you. Have a good day. Bye.
Thank you. Bye.